If your current data engineering project is basically a notebook or a CSV file and some hope, I'm not judging you. A lot of people start there. But if your goal is to get interviews, that kind of projects usually doesn't create much trust. Because recruiters and interviewers are not looking for someone who touched Spark once. They are looking for signs that you understand how data actually moves through systems. So let's do something useful. Hello everyone, welcome to Big Data Effect. I am Pranit and I have over 4+ years of experience working as a data engineer. In this video, I am going to show you one data engineering project that can do a lot of heavy lifting for you. It can become a strong GitLab project, a better resume bullet, and a solid project story in your interview. And the stack is simple and realistic: Spark, SQL, and AWS. By the end, you should be able to say something like, I built an end-to-end e-commerce analytics pipeline that ingests raw order data into S3, processes it with Spark, creates curated analytics tables, and uses SQL to generate business metrics like daily sales to products and repeat customers. That already sounds much stronger than I did a project on big data. So what's the project? Built an e-commerce analytics pipeline. Why e-commerce? Because it's simple enough to understand but rich enough to show your data engineering skills. You can use datasets like orders, payments, products, and maybe clickstream or event data if you want to level it up later. This project works because it naturally gives you 5 things that interviewers care about: ingestion, storage, transformation, SQL analytics, and a cloud awareness. That's why I like it. Not because it looks fancy, because it maps well to real work. So here is the project at a high level. You have raw data coming in, maybe from CSV files, maybe JSON files, or maybe from API response. That raw data lands in S3. Then a Spark job reads it, cleans it, standardizes schemas, joins related data, and creates curated output tables. Then your SQL layer answers useful business questions. That's the story. Source to raw storage to transformation, and from transformations to analytics output. Clean, real interview friendly. Now let me make it more concrete. The simplest version looks like this. You take orders, customers, products, and payments, store the raw files in S3 under separate raw folders. Then your Spark job does the real work. It cleans nulls and bad records, fixes data types, joins order data with customer and product info, filters invalid payment states, and creates curated tables like fact orders, dimensioned customers, and dimensioned products. Then your SQL layer answers useful questions: daily sales, top products by revenue, repeated customers, failed payment trends, revenue by category, monthly growth. That right there is a full data engineering project. Not because it's huge, because it's structured properly. And here is why this project is better than something generic like Netflix dashboard or sales dashboard using Python. Those projects usually show data analysis, but this project usually show pipeline thinking, and that's the difference. Now let's go step by step and make this project actually stronger. Step 1. Raw ingestion. Don't start with beautiful final tables, start with messy data. That's realistic. Even if you have downloaded static CSVs from Kaggle or another public dataset, structure them as if they have arrived from separate systems. For examples, orders data from one source, payments from another, customer data from another. Because in real life, data doesn't arrive folding hands. This matters because when you explain the project later, you can say, the pipeline handled data coming from multiple sources with different schemas. This sounds real immediately. Step 2. Store raw data in S3 exactly as it arrives. A lot of beginners skip this layer and go straight to transformation outputs. That makes the project look like analysis, not engineering. The raw layer tells the interviewer, I understand the source data should be preserved before transformation. That's a good signal. Step 3. Use Spark for transformation. This is where you prove the project belongs in a data engineer portfolio. Your Spark job should handle schema cleaning, null handling, typecasting, joins, derived columns, and partitioned output. You don't need 500 lines of code, you need clean logic. A good Spark stage might include converting timestamps, removing invalid rows, joining orders with customers and products, creating revenue fields, and partitioning output by date. That's enough. And if you want to sound stronger, mention one performance consideration. For larger data, I would think about partitioning strategy, join type, and avoiding unnecessary shuffles. Even if your sample dataset is small, that sounds mature. Step 4. Write curated output tables. This is where the project becomes useful. Your output should look like something analytics teams or downstream systems could actually consume. For examples, fact orders, daily sales summary, customer purchase summary. Try to write them in a clean format like Parquet. That tells the interviewer you understand the effective storage, not just correctness. Step 5. Add SQL analytics on top. This is where a lot of DE candidates miss a huge opportunity. Don't stop at the pipeline runs. Show that the output is useful. Write SQL queries that answer. What are the top 5 products by revenue? Which customers are repeated buyers? What is the month-over-month sales trend? What is the payment fail rate by day? These are business-shaped questions, and that matters because data engineers doesn't build pipelines for fun. They build them so that the data can be used. Now let's talk about what should go into the GitHub. Because if you build this and upload only the code, you're wasting half the value. Your GitHub project should include a simple architecture diagram, a short README explaining the flow, folder structure, sample input and output, 3 to 5 example SQL questions, and a short section on what you learn or future improvements. That README matters more than people think. Because recruiters don't always run your code, but they look at how you explain your code. And here is the part most people care about. How do you turn this into something useful on your resume? Like this. Instead of writing, build a Spark project using AWS and SQL, write, designed an end-to-end e-commerce analytics pipeline using Spark, AWS S3, and SQL to process raw order and payment data into curated business tables for reporting. Even better if you add numbers. Designed an end-to-end e-commerce analytics pipeline using Spark, AWS S3, and SQL to process 5 million plus records into curated analytics table for daily reporting. Now let's talk interviews. If someone asks, tell me about a project you built, this project gives you a very clean answer structure. First, explain the source. I used separate raw datasets for orders, payments, customers, and products. Then storage. I landed the raw files into S3 to preserve source data. Then processing. I used Spark to clean, join, and transform them into curated output tables. Then output. I wrote SQL on top of those outputs to generate business metrics like revenue trends and repeat customers. Then one challenge or future improvement. If I extend this further, I would add orchestration, data quality checks, and incremental loading. That's a solid interview answer. Now let me save you from the mistakes that make even a good project feel weak. First, you built only the code and forgot the story. Second, no architecture diagram. Third, no business output. Fourth, no data engineering language. And fifth, too much complexity too early. You don't need Kafka, Airflow, dbt, Terraform, and Kubernetes in version 1. A clean project beats a messy everything project. So here is the takeaway. If you want one project that can genuinely help you get data engineering interviews, build an e-commerce analytics pipeline using AWS S3 for raw storage, Spark for transformation, SQL for analytics, and a clean README that explains the full flow. That gives you a resume bullet, a GitHub project, and a real interview story. One project, 3 users. That's efficient. If you want, comment project, and I will make part 2 where I show the exact folder structure, project architecture, and sample resume bullet you can use. And if you're already getting interviews but struggling to answer questions, watch the next video in the interview series. I break down how to answer Spark, SQL, project, and AWS questions in a mock data engineering interview. This is all for today. We'll meet in the next video. Till then, bye bye.